Here we have a SAT math question. Okay, let's go with the information. If 3 more than the square of m is less than m multiplied by 4, what is one possible value of m? Okay, to find one possible value of m, what we have to do is we have to convert the given statement into an inequality. Okay, now let me consider the part of the given information, that is 3 more than the square of m. 3 more than the square of m means the square of m has to be increased by 3. Now let me write the expression connected to this particular part of the information over here. So m square positive 3. So this expression represents the information we have over here, 3 more than square of m. Now let's consider the second part, that is less than. Is less than means we have to write the inequality sign, less than m multiplied by 4, that is 4m. Okay, now we have to solve for m in this inequality. For that, let me subtract 4m from both sides. Let me do it. So when I do so, this positive 4m, negative 4m will cancel. I'm getting m square negative 4m positive 3 less than 0. Here we have a quadratic inequality. Okay, so now what I'm going to do is I'm going to factor the quadratic expression we have over here. For that, what we have to do is we have to multiply the constant of positive 3 by the coefficient of m square, that is 1. When I multiply this 1 and positive 3, I'm getting just positive 3. Okay, now I have to get two factors over here so that the product of the two factors equals to positive 3 and the sum of the two factors equals to the coefficient of m, that is negative 4. I think negative 1 and negative 3 will work. When I multiply negative 1 and negative 3, I am getting positive 3, and when I add negative 1 and negative 3, I am getting negative 4, which is the coefficient of m. Further, I have to divide these two factors by the coefficient of m square. In this case, it's 1. So even when I divide this negative 1 and negative 3 by 1, still I'm getting negative 1 and negative 3. Okay, now the first factor of this quadratic expression is m, and I have to take the value over here, m negative 1. And the second factor m, then I have to take this value, negative 3 less than 0. Okay, now I have factored the quadratic expression we have over here. Now I'm going to consider this inequality as an equation by replacing this less than sign by equal sign. Then I'm getting m negative 1 times m negative 3 equals to 0. Here we have the product of two binomials equal to 0. Whenever the product of two quantities is equal to 0, either the first one is 0 or the second one is 0. That is either m negative 1 equals to 0 or m negative 3 is equal to 0. When I solve for m in this equation, I am getting 1. That is I am adding 1 to both sides. When I do so, I am getting m equals to 1. And to solve for m in this equation, I have to add 3 to both sides. When I do so, I am getting m equals to 3. So when I consider this inequality as an equation, I am getting two values for m equals to 1 and m equals to 3. Now what I am going to do is I am going to plot these two values of m on the real number line. On the left side extreme, we have negative infinity on the real number line. On the right side extreme, we have positive infinity. Now we can write these two numbers 1 and 3 on the real number line in order. So 1 should come first and 3 should come next. So when I plot these numbers, the two values of m on the real number line, I can split up the real number line into three intervals. The first interval is negative infinity comma 1, and the second interval is 1 comma 3, and the third one is 3 comma positive infinity. Now what I have to do is I have to check each of these three intervals with the inequality we have over here. Okay, for that what we have to do is we have to take a random value in each interval, and we have to plug in that random value for m into this inequality and check whether the inequality is satisfied by that random value. Okay, now let me take the first interval, that is negative infinity comma 1. Now let me take a random value between negative infinity and 1, so that can be 0. Okay, now what I'm going to do is I'm going to plug in this 0 for m into this inequality. When I plug in m equals to 0 into the first factor, 0 negative 1 will become negative 1. When I plug in m equals to 0 here, it will become negative 3 and less than 0. So let's multiply this negative 1 and negative 3. Negative times negative is positive, 1 times 3 is 3, 3 less than 0. So clearly it's a false statement because a positive value cannot be less than 0. So the first interval, the random value I took in the first interval, negative infinity comma 1, does not satisfy this inequality. So we cannot have solution. That means we cannot have value for m in the first interval. Okay, now let me consider the second interval, that is 1 comma 3. Now let me take a random value between 1 and 3. So that is 2. Now let me plug in m equals to 2 into this inequality. When I plug in m equals to 2 over here, 2 negative 1 is just 1. And when I plug in m equals to 2 over here, 2 negative 3 is negative 1 less than 0. 1 times negative 1 is negative 1 less than 0. This is true because a negative value is less than 0. So the random value I took in the second interval 1 comma 3 satisfies this inequality over here. So it works. Now let me consider a random value in the third interval, that is between 3 comma positive infinity. So that is 4. Now let me plug in m equals to 4 into the inequality over here. When I plug in m equals to 4 over here, 4 negative 1 will be 3. When I plug in m equals to 4 over here, 4 negative 3 will become 1 less than 0. 3 times 1 is 3 less than 0. So here we get a positive value. A positive value less than 0 is false because a positive value can never be less than 0. So the third interval, that is 3 comma positive infinity, does not work. Only the interval 1 comma 3 works with this inequality. That is, m can take any value between 1 and 3. It can be written as 1 less than m less than 3. But the question is asking us to find one possible value of m. In this interval, one possible value of m can be 2.